All right, so let me give you a little bit of background on myself. I spent probably the last 20 plus years in the chemical sector, and my career has been over the past 20 years has been all around innovation, primarily out of the chemical sector. And most recently, I came across this technology um, to basically start to decarbonize some of the feedstocks. If you're at all familiar with what's going on in the chemical sector, they're struggling enormously with trying to decarbonize. And so when I came across this technology, I thought this is where the future is going to lie, because in many cases, the chemical companies can't decarbonize until their feedstock is decarbonized. And so I came across this technology, I joined forces with them, and we're kind of pushing it forward. Along the way, we initially had focused on the chemical sector, but in doing some investigation, and I'll talk a lot about it today, we discovered that the marine fuel market is one of the best areas to place our initial bets. So the technology is called Metasorbex, and it's basically taken the combination of CO2, combining it with hydrogen, and it doesn't matter whether it's gray, blue, or green. And the catalyst sorbent that's been created basically takes the CO2 plus the hydrogen and creates a zero carbon methanol. So why don't I get started on that? All right, so this is a pictorial here, which pretty much lays out the green, the blue, the gray hydrogen combined with the CO2 using the Metasorbex sorbent catalyst to create the zero carbon methanol. And the zero carbon methanol, from our perspective, can be used as a fuel feedstock to change the whole CO2 landscape where we can. The shipping industry is in desperate need of zero carbon fuel to meet their global fleet goals. And this provides a tremendous opportunity for us, we believe. The derivative markets, which I'll talk about later on, is also an area of potential opportunity. And they'll be a little bit slower to adopt. The faster market to adopt should be the marine fuel market. Okay. So at a very high level, this is how the technology kind of works. It's a sorbent technology developed out of the knowledge from the graphene industry. The gentleman who developed the technology actually worked for several years in the graphene industry. That's where I first met him. I was doing some work in the carbon nanotube and the graphene industry. It's a solid sorbent versus a liquid sorbent, and it's made out of commonly used materials that you can pick up off the market today. What a lot of challenges the market or the industry is having, and this happens to go with most innovation, where a lot of innovation occurs is by taking some technology out of one market or one industry and applying it to a new industry. And that's kind of what happened here. If you talk to people in the chemical sector, they don't really play with graphene very often. They don't play with carbon nanotubes. It's not a known technology that's commonly used in the chemical sector. And that's what provided the opportunity for this technology to take place. And again, like I said, the inventor comes out of the graphene industry. And he happens to be a chemical engineer from Caltech with his PhD in chemical engineering from Princeton. Much smarter than I am. So at a very high level, the sorbent technology has 10x absorptive capacity and 100x regenerative cycles. That may not mean a lot if you're not a chemical engineer, but these two combined features of being able to absorb 10x the capacity of CO2 and then the ability to regenerate this technology over and over again is what allows us to drive down the cost of the technology. Also, too, because of the use of CNTs and graphene, the heat generation is 8x lower. So you've got a lower operating expense, you've got a higher capacity throughput and regenerative, and those two combinations really is what helps to create a lower cost green methanol. Let's see. Moving down to the catalyst. Because of the graphene, because of the carbon nanotubes and how they're structured, the catalyst provides a very high yield and it lasts for a very long time. There's a bunch of patents that are being filed in this space, and we're continuing to take the technology out to the marketplace. So from a market perspective, here's kind of the way we're thinking about it. So our first path to market would be the fuel and chemicals market. And again, taking CO2 and hydrogen, creating the zero methanol for the downstream marine fuel market. Our second potential opportunity, and those would be working with the methanol producers, the Methanexes of the world and so on. They're going to be a little bit slower to adopt. The smaller and medium-sized methanol producers will be probably faster to adopt. And that's not to say that they wouldn't adopt faster, but big companies tend to adopt at slower rates. Smaller companies tend to adopt at faster rates. In the second go-to-market strategy, and this is a real, I'll call it a wild card. There's a lot of H2 production that's coming online and being built globally. And if you're at all familiar with the hydrogen production process, there's a lot of CO2 that's generated. So our technology, coupled with the capture of the CO2 at the hydrogen production point, can be looped back around, married up with the H2 to create basically a side stream. Today, a lot of the H2 producers are looking for ways to how to abate the CO2 production, because it does produce quite a bit. So some are looking at sequestering, some are looking at containment. And the way that we look at it is, why spend that money on abating as opposed to just looping it back around and creating a value stream of zero carbon methanol? And depending upon what market you're in, the cost, at least in the US, the cost is about $400 to $500 a ton for methanol. The cost of disposal or sequestering costs you anywhere from $50 to $75 a ton to get rid of. So here you're taking a waste stream product, and instead of spending money, you're actually generating money. And then the last option 3, would be working with downstream producers of intermediate chemistry, people that make methyl methacrylate, acetic acid, formaldehyde, and so on. And methanol is the building block to get to those materials. In a recent conversation with a very large coatings company out of Europe, they use a lot of methyl methacrylate. Their comment to me was, we are desperately in need of a zero carbon feedstock because we're up against the wall of being able to reduce our CO2 footprint until we start receiving zero carbon feedstock. So they're very excited. They're hopeful that this technology gets into the marketplace because it would allow them to better achieve their CO2 reduction goals. And this, I won't go through this real deeply, but when we look at the potential marine market, if we can find ways to partner with some of the methanol producers and potentially the H2 producers, the whole marine fuel market, and you'll see some of the big users of potential users of methanol as a fuel, you'll see that there's a lot of ways for them to be able to access zero carbon methanol. And so we're very hopeful that this winds up happening. This is just an annual consumption. I guess the real takeaway from here is you'll see in 2019, heavy fuel was the dominant source. And 1 year later, you can see that there's been a dramatic drop in the heavy fuel and a dramatic increase in the light fuel. We hope over time that methanol becomes the big dominant player in the fuel market. These are just some rough numbers. As the industry starts to move towards an e-methanol for marine, today the market size is relatively small, but as the market tends to look for ways of decarbonizing and lowering their CO2 footprint, it's anticipated that the marine fuel market for e-methanol could grow as much as from 4 billion to 218 billion. So that's an enormous amount of growth over the coming years. And so if this happens, this is going to dramatically change. In conversations I've had with a lot of methanol producers, they are continuing to expand and build additional methanol plants in order to meet this growing market. The market today is growing in the low 50 CAGRs, which means that this is probably where the future is going, at least in the marine fuel. This one is just a density chart, which shows the difference between the density of diesel fuel versus methanol versus ammonia versus hydrogen. So methanol is definitely more dense than ammonia and hydrogen, and there's been some talk about potentially ammonia or hydrogen being used as an energy source in the marine space. Shifting gears a little bit, when I was talking a little bit earlier about the hydrogen partners here, for example, it's just a small list of hydrogen producers who could take their CO2, loop it back around, make the methanol, and then they could supply that zero carbon methanol to people that would turn it into acetic acid, formaldehyde, and so on and so forth, as you can see there. The chemical partners, we talk about the methanol supply. There's an opportunity, again, like I said, to be able to partner with some of these chemical companies who actually, and that's actually how I originally came across this. I was looking at an opportunity to utilize this technology with my previous employer, who used to buy several $100 million a year of methanol to derivatize into other chemistries. Since we were a producer of CO2, we used a lot of methanol. The hypothesis at that point was, why don't we get into this technology and produce our own methanol? So there's a lot of options for the chemical industry as well. This is looking at some of the growth that we're anticipating in, not only, as I mentioned earlier, in the fuel market, going from 4 billion to 218 billion, but the acetic acid market's going to grow. All of these markets are growing and bringing on new ways of bringing low carbon solutions to the market, we think is a beneficial opportunity. Now, let me tell you a little about where we are today. We're a startup company. We are actively seeking investment partners from the industry. We do have a few VC investors in the technology, but having somebody inside the industry to us is really critically important, because we're just one component of their overall manufacturing story. And so part of what our goal and objective is to really find somebody in each part of the value chain who would like to partner with us, because driving technology, I discovered many years ago, is very difficult to push. It's a lot easier if you have other people helping to pull it through the system. So lining up partners in different positions in the value chain are critically important. Obviously, we'd like to have an active participant out of the marine fuel, out of the marine industry, the maritime industry, as well as somebody in the methanol or the H2 part of the value chain. And at the end, that's pretty much it. Let me take a break here, and there we go. So I went a little fast on that, but I said it was only going to be about 20 minutes. Does anybody have any questions or comments?
Oh boy, where to start?
Oh,
well, I'll wait with my questions first. I'll leave the word to Gijs and Jan. They can start with the questions.
Gijs, do you start? Or?
You can start. I'm still thinking about one. Yeah.
Thank you for the presentation. Can you elaborate a little bit more on the technology of the graphene and why this technology? What's let's say different with conventional methanol production based on hydrogen and CO2?
Yeah, that's also the real sticky wicket in terms of talking too much about it. Part of what I can say is that the technology provides the ability to absorb the CO2 at a better rate. And because of the graphene and the carbon nanotubes and its ability to withstand high temperatures for longer periods of time, the sorbent catalyst lasts much longer. So I can't get into the details of how, but if you're familiar with MOFs and you're familiar with some of the other technologies, ours works a little bit differently than your traditional catalysts. So
Thank you.
you're quite welcome.
Maybe I can start before Gijs is start thinking. Well, I had a few, but maybe start with the one thing you mentioned in between. That's the current price for methanol per metric ton in the States is about $400 to $500.
Correct.
Um,
So our pricing matrix, at least based on the work that we've done, is because we're going to have an overall lower cost to produce. We have the option. One of the things that's always troubled the chemical industry is everybody wants green, but nobody wants to pay more for green. And it's not just the chemical sector. I think it's everybody,
everywhere.
right?
Yeah.
Everybody wants green, but they don't want to pay for it. Well, what this technology allows us to be able to do is to position the cost of e-methanol through our process at or potentially below the cost of the current methanol. So let's say, for the sake of an argument, we come in at 10% or 15% lower than the average cost of regular methanol today. Somebody can choose to sell it at the exact same price as high carbon methanol and dramatically increase their market share, or they could take a slight premium to maximize their bottom line. So there's options here to either maximize your bottom line or to take market share without highly disrupting the market. We do believe that if somebody were to adopt this technology, have an overall lower cost profile, that they would price it in such a way to fill out their plant fairly quickly, still making the same margins they would make as if they were selling a high carbon e-methanol. That once the market starts to understand that I can get a zero carbon methanol at the same price as high carbon methanol, we think that the market shift will happen quite dramatically.
Well, but yeah, I'm a bit flabbergasted, as in you're offering a carbon neutral sort of green alternative at a lower cost as the conventional methanol.
That is correct. And we think that, and part of that really has to do with the conversion rate in the manufacturing process, right? So as I had mentioned in the slides earlier, based on our absorptive rate and our regenerative rate, it allows us to use less energy. It allows us to get a higher yield rate. And as a result of the higher yield rate and the lower operating costs, our final cost will be lower than the current conventional methanol. And, in an odd type of way to kind of talk about it, a lot of the technology that's driving the methanol market today was developed 30, 40, 50 years ago. And, a lot of these assets are old. They don't want to change. We're not talking about greenfield sites here. We're talking about bolt-on processes to existing infrastructure. If I was sitting here saying you have to build a whole brand new greenfield methanol plant, that's not going to go anywhere, because the catalyst is the differentiating factor. And I understand that a lot of these processes are built around the catalyst, but this catalyst is using some of the same catalyst technology that they're currently using. We think with a little bit of very minor change to the current process, they'll be able, it's pretty close to a drop-in solution. It'll work a little bit differently. So all that combined basically says by changing the catalyst system, it allows them to generate a lower overall cost of e-methanol. Why we think it's important for the ship owners to be involved is because they have the highest benefit of being able to access, one, an equal to or lower than cost than their current methanol. There's a big shift towards methanol to get away from diesel and bunker fuel, and it lowers their overall CO2 footprint. So we think they could become a very critical catalyst, no pun intended, to driving this change in the marketplace.
And are you already talking to ship owners at the moment, like the Maersk's or?
We're not, and part of the reason is many of them are very large, small government bureaucracies.
Got it.
And finding the right people to talk to is a challenge. So part of the reason why I'm doing this and why I talk to anybody who will listen to me is because I know that deep down inside, somebody knows somebody who knows somebody. And getting this story in front of the right person, it becomes very critical in terms of being able to develop relationships and partnerships. When you're a small startup company, you don't always have the inside links that maybe the large methanol producers have with some of these ship owners. So it's just a system of talk, and eventually, like I tell my partner, it's just like dating. We're going to have to date a lot of people till we find the Prince Charming.
Yeah, hopefully not too many people for you.
Yes.
So, but okay. So supposedly you have. I'm just hypothetically pointing something out. A dredging vessel that would like to make use of methanol, preferably
Correct.
carbon neutral methanol. I mean, your production process still needs to be bolted on. Let's say it's of course the first step in the entire logistical chain. So, how long would it take if you had like a large investment now, and at what point can you actually bunker, let's say first in port, but then maybe also offshore? What are the time lengths we're talking about?
Yeah, so the timelines. So let's say, for the sake of an argument, and let me just preface by saying that our technology development does not need a lot of money. Our maximum all in is about $11 million to scale this to. So because it's a catalyst technology, we've done the bench work. Now it's just scaling to the next level. So we don't need a tremendous amount of money. The shortest timeline would be 2 years. The maximum timeline would be 4 years. If we got, and the way we've broken out our investment strategy is a staged approach, right? So if we got more money on the front end, that timeline could be dramatically reduced. So there's always a function of time and money there. But the way we're looking at it, in a best case scenario, 2 years, we would be ready for full scale production. Because whenever you're bringing a new process along, there's a lot of make it before you're ready to scale it at large levels. But so let's say in the best case scenario, 2 years, that's 2025. Let's say in the worst case scenario, that's 2027. That still gives us plenty of time, 3 years, to start getting, to start having an impact towards 2030 carbon neutral goals. So we did have a long conversation with a very powerful VC investor 2 days ago. And his comment was, we've got to get on this immediately because we're running out of time towards hitting our 2030 goals. And I think there's a lot of anxiety right now in the marketplace around that. What's actually helping us, and why we're highly interested in the European market first, unlike Europe, the US has not put any financial penalties on people that don't achieve their goals. Europe smartly said, oh, if you don't hit your goals, you're going to pay for it. So there's a financial incentive for Europe to adopt lower carbon technologies. And so that's actually where we're finding a lot of energy, no pun intended, around this technology, is because it would help them dramatically reduce their CO2 footprint and achieve their goals for 2030.
And so which penalties are you mainly referring to? Would that be EU ETS or other kinds of incentives?
Yes, so there's, if you don't hit your goals, the EU will assess some fines. Plus, you have to buy your carbon credits off the open market. So if you take the cost of the carbon credits that you have to buy and you combine them with the financial penalties that the EU is going to impose, you've now dramatically increased your cost of operating for not hitting your goals. And for large consumers like a Maersk, for example, that's a lot of real money. That's the difference between having a very good year or a very bad year financially.
Yeah, I can imagine.
Yeah.
All right. I have another question.
Sure.
How do you think the world infrastructure is ready for an adoption for the hydrogen towards taking the hydrogen production into methanol production. Is there already enough infrastructure for that? Do we need more hydrogen producing?
Yeah, so there would be a slightly higher capex investment for a hydrogen producer to be able to get into the methanol. We estimate that investment to be around 30 million. So if you're at all familiar with the general cost to produce a hydrogen plant, 30 million is a rounding error, right? It's minor at best. And where and there's a lot of hydrogen projects taking place right now, because there's a lot in the market that feel that hydrogen is going to be an energy source of the future. One of the challenges, though, is how to transport, how to get the hydrogen to market in a safe way, right? We don't need to be basically putting hydrogen bombs on the roads and sending them all over the place. So the hydrogen producers can basically solve their CO2 problem by marrying it up with their hydrogen that they just recently produced. We believe that the smaller startup hydrogen producers will be in the best position to implement this technology as they start to build. So we're actively searching for people that have hydrogen projects on the books that are still in the design phase, working with them, because if they were to build a greenfield hydrogen plant, integrating this technology into their process, they have the best chance to have. And where that could potentially create some consternation in the current methanol supply chain is if, for the sake of an argument, the hydrogen producers realize that, one, this technology solves their CO2 problem, and two, allows them to move into a merchant market. As a side stream waste, if the price of methanol today is $400 to $500 a ton in the US, and you have a hydrogen producer whose main goal is to sell hydrogen, they may not care if the price of the methanol goes out the front door at $200 a ton or $300 a ton, because they're turning a waste product into a revenue stream. So they don't have to be at price parity. So if the hydrogen industry starts to adopt this technology and integrate it into their manufacturing process, they could supply a lot of the marine fuel and a lot of the e-methanol to the market at substantially lower prices. That'll put a lot of pressure on the methanol producers.
All right, clear. Thank you.
Yep.
Extremely interesting indeed. I had some questions on how the whole blue, green, gray hydrogen would fit into the picture, but basically what you're doing is the CO2 waste stream of the regular hydrogen reforming process is used as a feedstock, and then voila,
correct,
neutral. Yeah.
Correct. Yeah. So in that particular case, now part of what we will need to do, obviously, is the life cycle analysis. So a gray hydrogen may not be as friendly as a green hydrogen, of course, right? So a green hydrogen would be better. We believe that a green hydrogen would actually move us into a negative carbon position.
Oh wow.
Yeah. The challenges with some of the green hydrogen is it's an expensive process. So the hypothesis right now is, let's assume they get on a cost curve and the green hydrogen becomes more cost effective. Utilizing this technology would put you in a potential negative carbon position. So, play this out a couple steps. Imagine if there was green hydrogen producing an e-methanol at a negative carbon. Now, all of a sudden, you can purchase your marine fuel with a negative carbon balance and sell those credits into the marketplace. That's a win-win-win all around the board.
It's a nice proposition, yeah.
Yes.
I have one final question, maybe.
Sure.
You stated the marine fuel market is the fastest to adopt. In my opinion, they're usually quite slow.
Of course.
Chemical industries can be slower. I don't know, but what
they
do you
are.
think? Okay.
Well, part of the reason why we believe that the marine market is because the incentives are there, right? So if you, a lot of the ships are being built with dual capacity to be able to use diesel as well as e-methanol. The growth rate, the anticipated growth rate coming out of the marine fuel market is growing by leaps and bounds. So a lot of the very large methanol producers are building capacity because the marine industry has basically said, I want to start shifting towards e-methanol and replacing bunker fuel and diesel. Because even a carbon-based methanol has a better profile, CO2 profile, than a diesel or bunker fuel. So there's all the incentive to move in that direction to begin with. But now if you have, for example, a zero carbon or a negative carbon methanol, the incentive is even easier to adopt. And there's no reason why you can't blend our methanol with a regular methanol and still burn the same, right? The credit wouldn't be as much. So the ability to adopt is easier. That's why we're focusing on that.
Got it. Well, it's a shame I don't have 11 million on my bank account. Maybe a little more.
Somebody
does. Yeah, somebody does. Yeah, absolutely.
Somebody does. And we just have to find that person. You have to turn over a lot of rocks before you find something.
Absolutely.
So, but anyway, we're very excited about it. We've been at this probably for about 7 or 8 months now. And our initial strategy was, we think, off target. After a couple months, we backed up. We shifted gears after really coming across what's happening in the marine fuel market. Really changed our whole perspective and have us now focusing all of our effort and energy in that space.
Yeah, well, good to hear. Well, any listeners or viewers, they can directly contact you, I'm assuming?
Absolutely, they can.
Yeah.
Please feel free to post my information. I think if you're going to post the presentation, all my contact information is there. I really appreciate you, Vince, taking the time to set this up. And it's just a word of mouth situation right now. The more people that hear about it, and feel free to pass along the presentation to anybody within your network. And look forward to the future.
Likewise, we will. Thank you for your time, Joe.
Thank you, gentlemen. Have a good day. It was a pleasure meeting you, and hopefully down the road we get to meet face to face one day.
Thank you very much, Joe.
Thank you.
Bye-bye.
Bye.
Bye, Joe.